So here we're told that there are a total of 8,436 steel balls, and we're told that they're stacked in a pile. So you have one on top, and then 3, and then 6, and then 10. So the numbers go 1, 3, 6, 10. So first you have to look for a pattern, and you'll see that they are increasing. So this difference is 2, that's 3, this is 4. So next would be 15, and then 21, and so on and so forth. So these are actually called triangular numbers. That's just a general term for these types of numbers, which are the summation in these equilateral triangles. But let's not worry about the notation here. The key is we have to sum these up. So essentially what we're looking for is this summation, and whatever the nth layer would be, meaning how many of these layers are, that needs to add up to 8,436. So the key thing is, how do we find what the nth term here is? So if you notice here, 3, because we're adding just 2 more to it, so the second term is 1 plus 2, and then we add a 3 to it to get the third term, and then the fourth term would be we add 4 to it. So you'll notice that the nth term is the sum of the terms up to that position. So fifth term would be 1 plus 2 all the way to 5. So nth term would be 1 plus 2 plus 3 all the way to n. Now we know what this is. The sum of first n natural numbers is n times n plus 1 over 2. So that's the nth term here. Essentially, Tn is n times n plus 1 over 2. And we have to sum this from 1 to n. There are n of these. So essentially we're looking for I equal to 1 to n summation of that. And so I can rewrite this as summation n times n plus 1 over 2 I equal to 1 to n, and that would be half summation n squared plus n. I'm distributing the n here. And this would be a summation of n squared I equal to 1 to n plus summation of first n terms. This we know is n times n plus 1 over 2. And this is the sum of the squares of first n natural numbers. That's n times n plus 1 times 2n plus 1 over 6. So I just have to now algebraically clean this up. I'm going to factor n times n plus 1 over 2. So this would be, this becomes 2n plus 1 over 3. So I'm pulling out a 2 from here, and that's 1. So this becomes 2n plus 4 over 3. I can factor out a 2, and I have to multiply this with this. One of the 2's disappears in the numerator, and I'm left with n times n plus 1, n plus 2 over 6, because we have a 2 and a 3. So that's the summation. Now you can also check your answer. I would do that in the exam, 1, 3, 6, 10, 15. So I'll say, okay, if n is 5, my summation should be 25 plus 6, 31, plus 3, 34, 35. So if I replace n as 5 here, 5 times 6 times 7 over 6, indeed it is 35. So that expression is correct. Now the key thing is we need to find the value of n for which this sum is 8,436. Now this is a cubic equation. I don't want to be solving for n. So here we'll have to rely on the answer choices. So let me start with B, 38. If n is 38, do I get the sum? And I'm going to look at the units digit to see if that would be enough. So 3, this is 13. That's 19. Here the units digit would be 3 times 9 is 7, and this is 0, so it would end in 7. So that's not the answer. Let me try C. C would be 36, 37, 38. So I'm replacing n with 36 here. To C, this would give me the answer. So that's 6. So 8 times 7 is 56. 6 times 6 is 36. So that one looks good, but I will actually do the multiplication to make sure that I get the exact answer. 7 times 3 is 21, 26, 11, 6. So 1406 times 6. And indeed, I do get 8,436. So the answer is C.